Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring scatter plots and the correlation coefficient. Before we do, let's start with a couple of definitions. A scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. When data is graphed with a scatter plot, it allows us to determine the type and strength of the relationship between the variables. This relationship is called association. Now, in previous years, you learned about association and you learned the three types, that there was positive association, negative association, and no association. So let's just review what that looks like. So in our first graph here, this is an example of positive association. On the x-axis, they've graphed the time in hours, and on the y-axis, they've graphed the distance. So as time increases, the distance driven increases. In other words, as the value of x increases, the value of y also increases. So this is called a positive association. Both variables are increasing. Now, a negative association, in this problem, we have cell phone use and remaining battery. So as the cell phone use increases, the battery remaining decreases. So we say as the value of y increases, as the value of x increases, the value of y decreases. This is a negative association. Now, no association means the change in one variable has no effect on the other variable at all. In other words, on the x-axis we have number of siblings, and in the y-axis we have the average yearly income. So this is saying that there's no relationship whatsoever between how many brothers and sisters you have and the amount of your average yearly income. Now, there's a very popular saying in statistics that says association does not mean causation, because causation occurs when the change in one variable directly causes a change in the other variable. So sometimes things can be associated positively or negatively, but there's no causation. So in example 1, it says describe the association between the variables and determine if there's a causation. So in our first example, it says as the number of miles you drive increases, the amount of gas in your gas tank decreases. So our first variable is increasing and our second variable is decreasing. So this would be a negative association. Now, is there causation? And we could say yes, because the number of miles, as you increase the number of miles, that causes the amount of gas in your tank to decrease. So there's definitely a causal effect. All right. Here's another example. And this is a true example, by the way. As ice cream sales in the U.S. increase, the number of shark attacks also increase. So our first variable, ice cream sales, as it goes up, the number of shark attacks in the U.S. also goes up. So this would be said to be a positive association, because as one variable increases, so does the other. But is there causation? Are the increasing ice cream sales causing the shark attacks to go up? And we could say no. We don't know for sure what's causing it, but it probably has something to do with ice cream sales being higher in the summer, and in the summer there's more swimmers in the water, therefore there are more shark attacks in the summer. So ice cream, even though they're associated positively, there's no causation. Okay. The strength of an association between two variables can be measured how closely the data points are clustered together. So in example 2, I've given you 4 different scatter plots, and we're going to look at the data points and see the closer they are clustered towards a single line, the stronger their association. So for example, in problem A, we have a scatter plot here and a line of best fit that has a negative slope. And these points are all clustered very tightly around this line. So we could say that this is a strong negative association. In our second example, we have a line of best fit that has a positive slope, but the points are not clustered very tightly around the line. So we would say that this is a weak positive association. Pause the video and try the last 2 problems on your own. All right, welcome back. Hopefully on C, you put strong, positive, and D, you put weak, negative. If you got either of those incorrect, pause the video and fix them now. If you got them both right, let's continue on to talk about the correlation coefficient. All right. So when we're dealing with statistics, we have something called a correlation coefficient, and we use the symbol R to denote it. The correlation coefficient is a value between -1 and +1, and it's used to measure the direction and strength of a linear scatter plot. So, for example, if your R value, your correlation coefficient is 0, that would mean there's no relationship whatsoever between the variables. However, if your R value, your correlation coefficient, is bigger than 0 and smaller than 0.5, we would call this a weak positive correlation. In other words, if I told you that the correlation coefficient for a set of data was 0.25, I would know that they're positively correlated. As one thing goes up, the other goes up, but the points would not be clustered very tightly around the line of best fit. Now, if you're like 0.6 to 1.0, that would be a strong positive. So the closer you get to 1, like 0.9999, that's a very strong positive correlation. Likewise, on the other side, we can have a weak negative or a strong negative. So let's say you had a correlation of coefficient of -0.8. That's a fairly strong negative correlation, okay? But say your coefficient was -0.998, that would be a very strong negative correlation. All right, example 3. 5 correlation coefficients are shown below. Match each correlation coefficient to a scatter plot. So we have R equals 0.99, R equals 0, R equals -0.56, R equals -0.82, and R equals 0.35. So we're going to look at problem A. The first thing I want to do is draw a line of best fit through this data. And I want you to notice that the points are very strongly clustered around that line. And not only that, it is a positive slope. So we know we can eliminate any R value that is negative. We know this has to be a positive correlation coefficient. So our choices here for positive correlation coefficient are 0.99 and 0.35. But because these are clustered very tightly around the line of best fit, I would go with the 0.99. This is a very strong positive correlation. All right. Problem B. I would draw a line of best fit through this data, maybe looking something like that. We always want our line of best fits to kind of go through the middle of the data. So again, this is going to be a positive correlation coefficient, but it's much weaker than the previous one. So we're going to use the 0.35. All right, in problem C, there is no way to draw a line of best fit through this data. That's because there is no association here, and so that would be a correlation coefficient of 0. All right, try problem D on your own. All right, welcome back. Let's see how you did. I tried to draw a line of best fit through the middle of the data, something like that. So I know my answer's got to be negative, so let me highlight my negatives here. I have 2 of them. And the points are not clustered very closely to the line, so I wouldn't want to use the negative 0.82 because that's a strong positive. I would want to go with the negative 0.56. It's not a strong negative. It's more of a weaker negative here. All right, example 4. We can also use technology to calculate our correlation coefficient for us. To do that, we first want to make a scatter plot on our calculator of whatever data that's given to us. So in problem A, it says the table below shows the relationship between the gas mileage in miles per gallon of a car and its weight in thousands of pounds. So I want to make a scatter plot here. And when I make a scatter plot, the first thing I do is set up a good viewing window. Now I'm going to be using Desmos. You could use any graphing type calculator that you have. So on Desmos, to set our viewing window, we use this little wrench here. And for my x's on this table, my smallest x value looks like 3.2. My largest x value looks like it's going to be 6.8. So I'm just going to say that I need something between 0 and 10, and stepping by 1 is perfect, okay? Now, the y values, my smallest y value looks like 18. My largest y value looks to be 48. So I want to go something like 0 to, I don't know, maybe 60. And I don't want to go by ones because 60 hash marks is a lot. Maybe we'll just go by, say, tens, okay? All right, now, on Desmos, to make a scatter plot, you use this little plus symbol, and then you do the table. So I'm going to enter my values, 3.7, 38, 4.5, 26, 3.2, and 48, 5.1, and 24, 6.8, and 18. 4.9 and 29 and 5.5 and 21. All right, so there's my points. They've appeared up here on the screen. Now, to get my correlation coefficient on Desmos, I want to press, there's a little, at the top left corner of my table, there's a little scatter plot symbol. So I'm going to click that, and it'll draw a line of best fit. And then I come down here and look where it says statistics, and I'm looking for the R value. So I'm going to round this R value to 2 decimal places. So negative 0.9, I'll round that to 2. So negative 0.92. And the meaning of this is it is a strong negative association. A strong negative association. And then it says, does this relationship demonstrate a causation? In other words, did the weight of the car, does it have something to do with the gas mileage? In this case, yes. The weight of your car in general determines what kind of gas mileage you're going to get. So if you have a really large pickup truck that's lifted and it weighs a lot of, in this case, thousands of pounds, then yes, it's going to get very bad gas mileage. Okay, so definitely a causal relationship here. Now, let me delete that and we'll go to another example. In this next example, it says the table shows the number of firefighters required to fight a given fire versus the dollar damage done to the house by fire. So I want to first, whenever I'm making a scatter plot, set up a correct viewing window. So here, my largest x value, my smallest x value is 2. My largest looks to be 16. So I'm going to just go from, say, 0 to 20 here. And honestly, all of you could put something a little bit different here. My only goal is to be able to see the data points in my graph, okay? On my y-axis, let's see, my smallest amount of damage is $2,932. My largest amount of damage is $52,900. So wow, I'm going to have to go from 0 to, say, 60,000. And I will step by, say, 10,000s. Something like that, okay? Now press your plus symbol and then select table. And let's put our data in here. 229.32. 3 firefighters. The damage to the house was $97.50. 5 firefighters. The damage was $15,575. 8 firefighters. The damage $23,190. 9 firefighters. $22,900. 12 firefighters. $35,400. 16 firefighters. $52,900. All right, so we can see from our scatter plot, we have a positive association here, but we want to calculate our correlation coefficient, or the value of R. So I'm going to press the scatter plot button here, go down here to where it says statistics, and I want to round R to the nearest hundredth. So that would be 0.99. So this is a very strong positive association. But is it causal? Is it a causation? In other words, it is true that the more firefighters you have, the more damage you're going to have from a fire. But that doesn't mean the firefighters caused it. It just means if there's a very large fire, they need a lot of firefighters. But there is no causal relationship between the firefighters and the damage, okay? In other words, the number of firefighters did not cause the damage. It was the fire that caused the damage. But there is a strong positive association. And that concludes today's lesson, scatter plots and correlation coefficient.